11.5 Areas of circles and sectors. The area of a circle is pi times the square of the radius. So this is pretty standard. You guys should have seen this before. Area is equal to pi r squared. Let's use this formula to find the diameter of the CD that has the area of 113.1 centimeters squared. And to do this, we need to find the diameter. Since we're looking for diameter, we should do area is equal to pi r squared, and we're given the area of the CD, so we'll plug 113.1 in for the area, set that equal to pi r squared, and we can divide by pi on each side. This should give us roughly 36, and that will depend on how you round it and what you plug in for pi, but when you round you should get 36. Set that equal to r squared, square root both sides, and we'll get radius is equal to 6. And we're done, right? No, we are not. We are trying to find the diameter. So to find the diameter, we just need to take our radius and multiply it by 2. So our diameter is going to be 12 centimeters. And always remember, we've been saying this in previous lessons as well, it's always important to remember your label on every single answer. And this is diameter, so it's just going to be regular centimeters. And looking at some vocab. Sector of a circle. So a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. Looking down at our circle, it looks like a piece of pie has been taken out. It looks like somebody had cut it out, and that's represented by the red section of the circle. That would be section APB. And then theorem 11.10 is the area of a sector. So the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360 degrees. Okay, both of these formulas should look very, very familiar, but there's one key difference. What I'd like to draw your attention to is this part here. In 11.4, we went over circumference, and when we were trying to find an arc length, we would use the circumference. So we're trying to find the area of a sector, so we're going to use the area of a circle, which is pi r squared. And this still, the measure of AB, this right here, this is still your central angle. So this will still be your central angle, and you're still going to divide that by 360 degrees. And everything else will be the same and work very similar to what we've done in 11.4. Just remember, the only difference is we're using the area of the circle. And moving to example 2, find the area of the small sector formed by UTV. We're looking for the small sector, so we can say we're looking for our small sector over here. We can set that equal to our central angle, which is 70 over 360. And we would multiply that by, remember the area, we're going to multiply by the area of the circle. So we have pi r, which is 8, our radius, and we're going to square that. And if we were to simplify this all out, we should get 39.10. And we don't have a label on this one, so we're going to call it units, or U squared. That is because this is an area. Remember, we're finding the area of the small sector. Example 3, we're going to use the diagram to find the area of the large sector. And we need to find the area of the large sector. It's very, very tempting to come in here and just say, oh, well, we can write down what we're given. So we could say we're trying to find the area of the large sector, so we do 120 over 360 times pi, all multiplied by 14 squared. This is very tempting to do, so don't do it, because this is not what we're looking for. We're looking for the area of the large sector, so that would be the color blue. And we need to find this angle here. And in order to find that angle, we could just do 360, which is the entire distance around a circle, minus 120, which will give us 240. So this measure inside here will be 240 degrees. Now, the correct way to do this, to set this up, would be to say the area of our large sector. So I'm just going to say area of LS, large sector, is equal to 240, because that is our central angle here, divided by 360, multiplied by the area of a circle, which is pi, and our radius, so 14, squared. And if you were to plug this into a calculator and simplify, you will get 410.50 feet squared. Now, this is feet squared because, once again, we're finding the area of the large sector. So whenever we're finding the area, we have to make sure that we square our units. Example 4. Use the diagram to find the area of the circle with center V. And we are looking for the area this time, and we're looking for the area of the entire circle. And we're given the area of the small sector, which we can use to find the area of the entire circle. We know the area of the small sector is 35 meters squared, and we can set that equal to the central angle, which is 40, and put that over 360. And in this case, I'm just going to multiply by A, which represents the area. This is similar to a problem we've done with the circumference. We're looking for the circumference of the circle, except this time we're looking for the area of a circle. And you could solve this by plugging in pi r squared, but then you would have to plug your radius, which you would, because you would find r, you'd plug your radius back into your area to get your answer. So basically we're going to do a simpler version. And continuing solving this here, we can simplify this and get 1/9 of the area is equal to 35. Multiply each of these sides by 9. And our area will be 315 meters squared. Because once again, we're finding the area, so it's 315 meters squared. Example 5, find the area of the figure. Just looking at this, it looks difficult, it looks different, it looks weird. However, all we need to do is just find the area of two different regions. We've done this before. We did this in 11.1. And looking at this, let's break it down. So the first thing we're going to do, I'm going to call our triangle, we're going to call this A1. And we're going to call our semicircle A2. So we have area 1 and area 2. And I'm going to find area 1 first. Area 1, and we can use the area formula for a triangle, which is 1/2 times the base, which our base here of this triangle is 7, and we're going to multiply by the height. And remember, the height is the line that creates a right angle with the base. Therefore, our height here will also be 7, because that is the line that creates the right angle. And if we multiply this all out, 7 times 7 is 49, half of 49 is 24.5. And so we found the area of our triangle. And now what we can do is find the area of our circle. So if we're looking to find the area of our circle, which is represented by A2, we have pi times our radius, and our radius here would be 3.5. You might ask, where did 3.5 come from? Well, if you look up here at the circle, we are given the diameter of our semicircle here by 7. So all we had to do was just do 7 divided by 2, which will give us our radius. And we're going to have pi times 3.5. Now, we only have half of the circle. So if we only have half of the circle, we could multiply by 1/2 or divide the entire thing by 2. Either one is going to work. And once we do that, we should get 19.23 for the area of our semicircle. And to find the area of the entire figure, the entire region, we need to do 24.5 plus 19.23, which would give us 43.74 meters squared. Meters squared. Remember, we're finding the area of the figure, which will give us 43.74 meters squared. Here's a bonus question. I'd like you to pause the video now and try to get this on your own. Okay, that should do it then. Let's try to figure this out. It says find the area of the shaded region. So I have the entire region. So the entire region is made up of a rectangle, and the area formula of a rectangle is going to be base times height. Our base here is 18, and our height here is 6. And since we're trying to find the area of the shaded regions, which would be these areas that are shaded, we need to take out the areas that are formed by the circles and semicircles. So if we're going to take them out, that means we're going to subtract these areas here, 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 and here from our entire figure. And if you look, we have not one or two, but we have 3 circles inside. That's because we have circle 1, circle 2, and these 2 semicircles together will make up circle number 3. And that means we have 3 circles, and we're finding the area of these circles, which would be pi times the radius. And our radius here, be careful, we just had this in the previous problem. This entire diameter here is 6. So we need to do our diameter divided by 2, which will give us 3, and we need to square that. So if we were to multiply these all out and simplify, we should get 23.18 feet. Remember our label, feet, and it's an area, so it's feet squared. And this concludes the video for 11.5.